So here's the summary of the derivatives in this section. So ito yung formula natin sa exponential at saka logarithm. For exponential, we have the derivative of e raised to u with respect to dx equal to e raised to u multiplied by du all over dx. So pag ganito, we're going to check it first. What's the value of our u? So if you know the value of our u, then we're going to get their derivatives, du. Okay, so with that, e to the u multiplied by du all over dx. Next, for the second one, the derivative of a raised to u with respect to dx. For this time, a is constant. Then u, the same procedure. We have a raised to u ln a multiplied by du all over dx. Which means, again, look for the value of u and then find the first derivative. Because we're going to multiply it here. A raised to u ln a multiplied by du all over dx. So these are the two formula for the derivatives of exponential functions. Next, for the logarithm. The derivative of ln u with respect to dx is equal to 1 all over u multiplied by du all over dx. So the same procedure, look for the value of our u and then get the derivative. Then another formula for the logarithm. The logarithm of our u to the base a with respect to dx is equal to 1 all over u ln a multiplied by du all over dx. So again, find our u, what's the value of our u, and then get the first derivative. So with that, we are now going to have our example. Now let's have our example. For our first example, number 1, differentiate rw is equal to 4w minus 5 log w to the base 9. So there are two terms, no? So the first term, we're going to use your formula, this one. Since 4 is constant, so we have a raised to u. So we have a raised to u ln a multiplied by d all over dx. For this one, our a is equal to 4. Our u is w. So the derivative of w is equal to 1. Because 1, w raised to 1 minus 1 is 0. That is equivalent to 1. Okay? So with that, a raised to u ln a multiplied by du all over dx. But our du is equivalent to 1. So therefore, the first derivative of 4w is equal to a 4w ln a. That is our answer. Next, for the second term, 5 is constant. Again, log w to the base 9. So our a is equal to 9. Our u is w. So if we're going to get our derivative of w, that is equivalent to 1. So we're going to apply this formula. 1 all over u ln a multiplied by d all over dx. So since 5 is constant, we have here, so 1 all over u, which is w, ln a, that is 9, then multiply by du, which is 1. So therefore, our answer is 5 divided by w ln 9. That is our answer. Next, example number 2. Differentiate 3e to the x plus 10x cubed ln x. So with that, 3 is constant. So we're going to get the derivative of e to the x. Okay? So we're going to use this formula. We have e raised to u. By this time, our u is equal to x. We have e to the x. And our derivative for x is 1. So with that, 3e to the x, we're going to get the first derivative. So we have 3e raised to u, which is x, multiplied by du. Du is 1. So the derivative of our first term, 3e to the x, is the same as 3e to the x. Next, for the second term, it says that not much to do with this problem. Differentiate its term using the derivative of exponential and logarithmic functions. Just remember to use the product rule on the second term. So our next problem is our second term. 10x cubed ln x, which means your 10x cubed, that is our u. Ln x, this is our v. So we have u multiplied by v. From our formula, u times v, we have v du plus u dv. So we have v ln x du, derivative nito, 3 by 10, we have 30x squared. So we have v du plus u. This is our u, 10x cubed. Derivative ng ln x or ln u is equal to 1 all over u multiplied by du all over dx, but that's equivalent to 1. So 1 all over x. So simplified further, we have 3e to the x plus 30x squared ln x plus x cubed x, we're going to cancel. What's left will be 10x squared. So that is our first derivative. Next, you have your example number 3. Differentiate 5e to the x divided by 3e to the x plus 1. Solution, again, differentiate its term using the derivative of exponential and logarithmic functions. Again, you're going to use the quotient rule. This is our u, this is our v. Formula will be v du minus u dv all over v squared. So if we're going to apply that one, this is our u, this is our v. So formula, v du. So this is our v, derivative nito, 5e to the x, is the same as 5e to the x. So we have 5 v du minus u. This is our u, then dv. Derivative ng 3ax is same as 3ax. Derivative ng 1 is 0. So our dv is 3e to the x. v du minus u dv all over v and then squared. So simplify it further, 5 by 3 is 15. e to the x, we have e to the 2x. 5e to the x by 1, we have 5e to the x. 5 by 3, 15. e to the x, we have e to the 2x. So with this, collecting like terms, 15e to the 2x, 15e to the 2x, we're going to cancel. What's left will be 5e to the x divided by 3e to the x plus 1 and then squared. So that is our answer. Okay, so we're already done with your logarithm and exponential functions. By this time, we have the last topic, which is the derivative of hyperbolic functions. So for short, here are the 6 derivatives of hyperbolic functions, or your 6 trigonometric functions. Derivative of sine h, h represents your hyperbolic functions. Is equal to cosine h x. Derivative of tangent h x equals secant h squared x. Derivative of secant h x is equal to negative second h tangent h x. Okay? So by this time, we have your the negative sign. In your 6 trigonometric functions, derivative second x is positive second x tangent x. But in our hyperbolic, we have negative. Okay? So this one is negative. Next, we have the derivative of cosine x with respect to dx. By this time, we have positive sine x. Now, just like in your trigonometric functions, the derivative of cosine is negative sine. But for hyperbolic, this one is positive. Derivative of cotangent x is equal to negative cosecant x squared x. And the derivative of cosecant x with respect to dx is equal to negative cosecant x multiplied by cotangent x. Okay? So this is our formula for the 6 derivatives of hyperbolic functions. So they are almost the same with our 6 trigonometric functions. The difference there is may negative dito and this one is positive. Okay? So we're going to have our example. Number 1, differentiate f of x equal to 2x raised to 5 multiplied by cosine x. Okay? So solution, use the product rule and differentiate each term using the derivative of hyperbolic functions. So with this time, there are two functions. This one, 2x raised to 5, represents our u. And cosine x represents our v. So from our formula, the derivative of u times v is equal to v du plus u dv. Okay? So if we're going to apply the product formula, we have now f prime is equal to v, is our v. Derivative for this one, 5 times 2 is 10, x raised to 5 minus 1 is 4. So we have v du. Okay? Plus u. This is our u, 2x to the 5, and derivative of cosine x from our formula is positive sine x. With that, this our derivative of cosine x is sine x. So from our formula, v du plus u dv. So our answer is 10x to the 4th cosine x plus 2x to the 5 sine x. So that is our answer. Okay? Next, differentiate. I think this is the last example, no? H of t is equal to sine ht divided by t plus 1. Solution, use the quotient rule and differentiate each term using the derivative of hyperbolic functions. So what is our formula? U divided by v, this is our u, and this is our v. So formula for quotient, we have v du minus u dv all over v squared. So we have v. Okay? Our v is t plus 1. Then du. Derivative of sine ht is cosine x. So we have cosine ht. Minus u, our u is sine ht. dv, derivative ng t is 1. Derivative ng 1, constant is 0. So we have dv is equivalent to 1. Divided by v squared. So we have t plus 1 and then squared. So therefore, h prime is equal to v du minus u dv all over v squared. So we have t plus 1 cosine ht minus sine ht divided by t plus 1 and then squared. So that is our discussion for today, which is all about the derivative of six trigonometric functions, the derivative of exponential and logarithmic functions, and also with the derivative of hyperbolic functions. Thank you.